All right, we're going to take the next step now. Hopefully, you have understanding of this idea of electric potential. We equated it to this gravitational potential. Notice the difference. With gravitational potential energy, we actually talked about how many actual joules of energy you had. When we just talk about potential, we're talking about the ratio. With gravitational potential, we're talked about how many joules that, say, a rock had based on its mass. So you could put any mass there and just figure out the amount of actual energy. The same thing's true now when you equate it to electrical. It has a certain amount of joules per coulomb of charge at that location. So you could apply it to any object that you put there as long as you know the amount of charge it has in coulombs. We talk about increasing and decreasing its potential energy. It's going to decrease if it goes where it wants to, where the field wants it to go. You're going, and so like dropping the object, the rock dropping, it's going with gravity. That's decreasing the amount of energy, potential energy at least. Total energy, remember, stays the same. If you lift it, you're going against gravity's field lines, you're increasing the potential energy. Same thing is true with electrical. If you move that charge with the field lines or where it wants to go, you're dropping it, you're decreasing the amount of potential energy. If you're moving it where it doesn't want to go, you're forcing it there, you're putting in the work, you're increasing its amount of potential energy. Okay. So now we're going to tag in another term called potential difference. Again, it's always been there with gravity. We just never used it. It's not really that useful when we talk about gravity, but we'll kind of equate it to that as well and then convert it into potential energy. So at this point, you should have an understanding of electric potential energy, electric potential, which we just talked about. Okay. When you see this term electric potential energy, that's simply the amount of joules that you have. That's the actual amount of potential energy, stored energy. Electric potential is that ratio of the amount of joules per coulomb of charge at that location. Now we're going to talk about something called potential difference today. In this case, if you took a positive charge and you went from A to B, you would be increasing its amount of potential energy because A doesn't want to go against the field lines because it's a positive charge. Remember, these field lines are always drawn in reference to a positive test charge. If you went from B to A, you'd be dropping its potential energy because that is where it wants to go. All right. So and that's what we're just saying here. Okay. Moving it again, just think about in terms of with the field lines or against. Okay. Or where it wants to go. Okay. You're going to be dropping or decreasing the amount of potential energy. If you go against the field lines, okay, where it doesn't want to go, you're going to be increasing the amount of potential energy. Okay. So whether you're putting work into it here or work is your gravity is doing the work. Okay. So are you fighting it or are you working with it? Fighting it down here, going with it and working with gravity in that case, or now with the field lines, the electric field lines. All right. So whether you're going from A to B or B to A, you're going to have a difference, okay, in the electric potential energy between two locations. So when we start talking about potential difference, we're talking about the difference of the amount of electric potential that is at location, let's say A versus B. So we're literally looking at the amount of joules per coulomb at one location, say A, and we're looking at the amount of joules per coulomb at, say, location B. And we're looking at the difference. So if you went from A to B, what's the difference in potential? Not potential energy, but potential. So the difference in electric potential is represented by a symbol capital V. Now, this isn't quite yet what we talked about with voltage, and we'll get to that later on, but it's related. Okay. It is formally, and that's why you see it written this way, as the amount of electric potential difference. By definition, again, difference, think of subtraction. It is simply the difference in potential, electric potential between its final and its initial location. Okay. So when we look at this, we're looking at the amount of potential at location A versus B and finding the difference between those two. And that's what we're talking about with potential difference. So delta, remember change in old school to always told you, always think about it being final minus initial. Okay. So in this case, what we're looking at is potential difference is the amount of potential at B minus the potential at A. It is also equal to the amount of work, which will come into play, divided by the amount of charge per coulombs of charge. It is also equal to the change in potential energy per charge. Remember, that's just your work energy theorem. Okay? So there's just three different ways to write this. But we're just looking at the difference in the amount of potential from B to A. Remember, we're just talking about joules per coulomb. This is not the amount of potential energy, it's potential. Okay. The standard unit, the metric unit we use for potential difference is the volt. So you can see here in a couple lessons, we'll get into this term voltage. They are very closely related. It is just as it is capital V, okay, and it is in honor of Alessandro Volta. Okay, 1 volt is equivalent to 1 joule per coulomb, which is shouldn't be too off the wall for you if you look at the equation. And we looked at it's the difference in potential, and potential was joules per coulomb. So if you're just looking at the difference, the units aren't going to change. Okay? So if the electric potential difference between two locations is 1 volt, then 1 coulomb of charge will gain 1 joule of potential energy when moved between those two locations. Okay? If the electric potential between the two is 3 volts, then 1 coulomb of charge will gain 3 joules of potential energy when moved between those two locations. Okay? And notice I use this example of 1 coulomb of charge. If you did two, then it would gain 6 joules because of the ratio. Okay? 3 volts, 3 joules for every coulomb of charge. Okay, real short lesson. Just again, big things and takes ways to understand the difference between potential energy, okay, potential, and now you have potential difference. Here you're talking specifically how many joules of actual energy that object has at that location. This, when you talk about potential, is more of a generic. It is a ratio of joules per coulomb. Potential difference is how much it's gaining or losing based when you move it from one location to the other. It is looking at how much potential it changes from two locations. And again, 3 volts, say, tells you that it's going to gain 3 joules of energy when you move it from one location to another per coulomb of charge. So when you talk about a 9 volt battery, if you move a charge from one terminal to the other, that's telling you you are going to gain 9 joules of energy for every coulomb of charge.